Hi, welcome to a brief tutorial on naming and writing formulas for compounds which contain polyatomic ions. You'll remember, of course, that polyatomic ions are groups of atoms bonded together covalently which have then collectively gained or lost electron. Things like our friend nitrate here. Note that I have not drawn all the resonance to save space. Or our friend the sulfate ion. Or ammonium ions. Okay, so that's what polyatomic ions are. Now the thing is, you can form an ionic compound with one of these and a regular monoatomic ion. The rules are the same as those for naming binary ionic compounds. There are just a few tricks to be aware of. So, to start off, you'll need a table listing common polyatomic ions. Here's one. You'll note that this one, and this is the one that my students use, has your positive ions, or your cation ions, listed at the top. And commonly we really only have two polyatomic cations, the ammonium ion and the dimercury ion. They're further organized by charge. So while all the anions are down in this section of the table, the anions with a -1 charge are in the first column, those with a -2 charge are in the second column, and those with a -3 charge are in the third column. Helpful to be familiar with them. We'll start off with some simple formula writing. So, just as in binary ionic compounds made with monoatomic ions, the rules are the same in that the cation always goes first and the anion always goes second, and then when we get to naming, compounds are just named for the ions that they're made from. So let's look first at a compound made of calcium ions and carbonate ions. Just as we've done before, your first step is to write the ions. And you know that calcium forms a 2+ ion because it's of its location in group 2 on the periodic table. Now the carbonate ion is going to take some looking. Because calcium's positive, we know that carbonate must be an anion, so we know we're looking in this part of the chart. And if we look down the list, we pretty soon come to the carbonate ion. A little hard to read on here, but the carbonate ion is CO3 2-. Now, just as we did with binary ionic compounds made with monoatomic ions, we're going to do a crisscross. Okay, so we've crisscrossed. Our next step would typically be to simplify, but I want to point something, well, let's simplify first. We get CaCO3 as our final answer, and in fact that is the formula for calcium carbonate. Let's do a couple more examples. Okay, let's look at a compound made of ammonium ions and chloride ions. Again, just as before, we write the ions and their charges. And we realize that ammonium is not an element, so we know we have to go looking. Ammonium is right here, one of those very rare polyatomic cations. So ammonium's NH4 1+. Whoops. And the chloride ion is, of course, Cl1-. You know that because of its location in group 17 in the periodic table. We crisscross, and we get 1s in both cases. So our simplification is just a matter of cleaning up. And as a matter of fact, NH4Cl is the correct formula for ammonium chloride. Let's try one that has a bit of a twist. Let's look at a compound made of sodium ions and sulfate ions. As always, we write our ions and charges, and we write sodium, Na1+, knowing that it's in group 1 of the periodic table. But sulfate, something rings a bell. We've been working with sulfide ions, which are a single atom of sulfur that's gained 2 electrons, S2-. But this is sulfate. Sulfate is a polyatomic ion. And if we look on the periodic table, we find it right here. SO4 2-. It was actually shown here on this slide. So, we need to write the sulfate ion and do our crisscross. No need to simplify, just cleaning up. That 1 would be there. Now, this is a good time to mention, you need to be careful whenever you have a subscript outside of a polyatomic ion to ensure that the subscript on the polyatomic ion is kept separate from any subscripts that exist within the ion. When we do have a subscript in the final product, we put the polyatomic ion in parentheses. It's not necessary if there is no subscript on the polyatomic ion, so that won't be necessary as soon as I clean up the formula. Okay, Na2SO4. We're going to do one more, and then we're going to talk about naming. Okay, we're looking at a compound made of barium ions and nitrate ions. Again, we want to write the ions and their charges. And we have barium 2+, which we know because it's in group 2 on the periodic table. Nitrate. This is another one where caution should be taken. Just like with sulfate, we've dealt with nitride ions, which are a single nitrogen atom that has gained 3 electrons, but this is a nitrate ion, and it's right here. You do have to be very careful about those endings. Okay, the nitrate ion is NO3 1-. So we'll do our crisscross, which gives us something like this. We have to be very careful here, and this is where those parentheses come in real handy. So we'll clean that up, get rid of the 1, and we have something that's often spoken as BaNO3 2 times. That is the correct formula for barium nitrate. So now a brief conversation about writing names when given formulas. When given a formula that contains a polyatomic ion and asked to write a name, it's helpful to remember that the rules are identical to those for naming binary ionic compounds made with monoatomic ions. All you're looking for is the name of the cation and the name of the anion. Pretty easy to see, and as you do more of these, you'll get really familiar with the common anions and you'll be able to see them immediately. So, what is this? Well, that's a sodium ion. That's a nitrate ion. This stuff is sodium nitrate. Let's look at the next example. Okay, so when we look at this, the first thing we see is nitrogen, then hydrogen. This is an ammonium ion. And once you're used to seeing them, you won't ever make this mistake again. But some people want to make this nitrogen, hydrogen bromide. Terrible idea. Remember that NH4 is traveling together. And as a matter of fact, you know that if this was something with nitrogen, the nitrogen couldn't come first. Nitrogen forms an anion, but ammonium is a positive ion. So we have an ammonium ion traveling with a bromide ion. This is ammonium bromide. Okay, last one. When we look down here, we see 3 magnesium ions and 2 of those. Oh, what are they called? You'll need your chart to look it up. But it's a sulfate ion. So this is magnesium sulfate. Okay, things to remember. When you see an IDE ending, you're looking at something that is monatomic. It's made of a single ion, and you should be looking for the name of that ion on the periodic table. When you see an ITE or an ATE ending, these are polyatomic ions, and you should be looking on your polyatomic ion chart. So let's do a couple examples. So, when you see a reference to a nitride ion, or you see something that's sodium nitride, you're talking about a monoatomic, N3-. When you see a reference to the nitrite ion, you're talking about NO2 1-. And when you see a reference to the nitrate ion, you're talking about NO3 1-. It seems confusing at first, but as you practice, you'll get the hang of it. So go practice.